In this Algebra 1 video, we're mostly going to be dealing with what we call Chapter 4 this year, but we're dealing with standard MA.912.A.3.10. This is the standard all about linear equations, writing them no matter what information you're given, parallel lines, perpendicular lines, but also word problems, the match equations to word problems. So the specific standard says, write an equation of a line given any of the following information. I like to break these down into three scenarios. Scenario 1, you'll be given just 2 points that are on the line. Scenario number 2, you'll be given its slope and one of the points, or scenario 3, just its graph. Also, you need to be able to find an equation that's parallel or perpendicular with the same type of information they'll give you, like I just already mentioned. And I'll leave this page with the last thing I'll tell you, remind you, parallel lines have the same slope and perpendicular lines have opposite reciprocal slopes. And I'll show you what that means in a little bit, in case you don't already know. Okay, so some perspective. Let's talk about the different forms of linear equations. These are the three main forms, and these are the same three forms that will also be on your algebra reference sheet. You first got standard form. As a side note, everything I've marked in red, didn't mean to use the line tool, everything I've marked in red, those are things that will be actual numbers. Anyway, standard form, ax plus by equals c. Notice, x and y are on the left side, and c will be some regular old constant number, like 5 or something, out there by itself. You know a question, if it's a word problem, will be standard form when you notice both of your unknowns, x and y, whatever they are in the question, both of them will be happening more than once, meaning they'll be multiplied by something. The difference of that is a lot of questions tend to be slope-intercept form, and you know it when one of the numbers they give you happens more than once, and somewhere in the question there's a one-time happening thing, like a flat rate or a sign-up cost or a one-time fee or a setup fee, whatever. Anytime there's a one-time amount and there's a amount that happens more than once, that's going to be slope-intercept form. That's how it stands out to you. Whereas standard form, both of your unknowns happen more than once. Now this guy in the middle is called point-slope form. Point-slope form gets his name because you need a point and a slope, and that's all you need to plug in. Your x-coordinate goes here, your y-coordinate goes here of your point, and your slope goes here. Slope-intercept form also gets its name because of what you need. You need the slope, which goes here, and you need the y-intercept, which goes here. So that's the difference between these different forms. The good news is, the way these forms can be turned into each other. So if you needed this to become slope-intercept form, you could subtract whatever that x term was to the other side, and then you'd have by equals negative ax plus c. That's really sloppy. Then you divide both sides by b, meaning the coefficient of y. And once you did that, you would have y all by itself. Or vice versa. If you wanted to turn slope-intercept form into standard form, you totally could, because notice standard form has the the x and the y on the left side. So all you gotta do is move this mx term to the other side. And then you would have x on the left, and then you have just that regular number on the right. The only difference is, for standard form, we try to write an equivalent version of this so that we have no fractions, okay, no fractions here, and we like to avoid negative leading coefficients if we can. That tends to be the format you'll see if it was a multiple choice question. Now the final good news I'll say is, in class, the way we learn this, if we ever had to write an equation from scratch, we learned how to do it with the point-slope form, because no matter what the question is, you can start with the point-slope form, and the good news is point-slope form is relatively easy to turn into both forms. If you're turning it into y-intercept, slope-intercept, you get y by itself. If you're turning it into standard form, by the way, both those questions start out by distributing. Now if you're turning it into standard form, whatever this mx term is, you'll move it over here, and then you move this y1 term over here. That would put it in the standard form. Now if you're putting it in slope-intercept form, you would still distribute, then all you do is move this over here and you'd be done. And then it would be in slope-intercept form because y would be all by itself. So point-slope form turns into the other forms. Now that was a lot of me to say with just some symbols and some arrows. We will do some examples, but I want to give you some perspective of that. And just remember what I already said about parallel and perpendicular lines. Parallel lines have the same slope, perpendicular has opposite reciprocal. These notes should look familiar. These are notes straight from the video on writing slope-intercept form. And just a reminder, basically anytime you need to use point-slope form, and no matter what method you use, you always got to start by finding the slope if you don't know it already. So start by finding your slope using the slope formula. The slope formula is also on your reference sheet. It will help you memorize it, makes you comfortable. It's change in y over change in x, or rise over run, whatever you call it. But basically, once you have your slope, you take your slope and your ordered pair, and then you plug those into their spots of point slope form, and then turn it into whatever you want. All right, let's do some examples. All right, the questions you're going to see us do from the EOC review, these are the questions we're going to do. There's 8 of them, but notice there's a lot of repeats on types of questions. So, for example, you'll notice you need a slope-intercept form when you're given the slope and the y-intercept. You need to find slope-intercept form, and it'll be a word problem. So the first 2 questions are the same. And then this last question, number 68, is the same. But then notice here, they're the same type of question, but instead of the y-intercept like they were here, they're giving you just a point. And you might not realize it's a point. And I'm going to show you how to know it's a point when you're reading a question. So we're going to start off with these ones that are all the same. Let's start off with interpreting slope-intercept form. So let's start with number 4. Okay, so with a lot of word problems, I tend to like to read the last sentence first. It helps give you perspective. I'm not saying don't read the rest of the question, but it's a good test-taking strategy. All right, so I'm going to start here. Which equation best describes the total amount of Jesse's monthly phone bill? We're calling that amount T. In terms of M, the number of minutes of long-distance calls she makes. So in other words, this is already implying the amount of minutes she uses causes the cost. So because this is the one that causes the other, this is like what we are used to thinking of as our X term. This is your input. This is your independent variable, or your domain. And T is your output, or your Y, or your dependent, or your range. So just think of it that way. All right, now let's read the question. Each month, Jesse's phone bill includes a $25 basic fee plus a charge of 7 cents per minute for the number of minutes of long-distance calls she makes. I think they're implying that local calls are free. All right, anyway, but this basic fee, I think you'll notice, it doesn't imply it's happening more than once. So that basic fee happens only once. So it's not being multiplied by anything. Okay, whereas that 7 cents per minute, that the word per is the giveaway, or if it says for every, or if it says rate, that happens more than once. It happens however many times we have minutes, however many minutes we have. But that rate, if one of them only happens once and the other one happens more than once, that means this rate is your slope. So that tells you that's going to be your slope. So we realized this was going to be slope-intercept form, not just because I told you so, but because you notice one of your front numbers, one of your amounts only happens once, but the other one happens more than once. So as far as x and y, if you were to think of it that way, we only have one known. We only have one unknown is how many minutes she uses, but the other unknown is the total cost. But the total cost in this case is a direct output of the input, meaning we'll know the total cost once we know the number of minutes she uses. So that's kind of how you knew y was going to be by itself. Alright, so I got my slope-intercept form set up. Y equals blank x plus, or it could be minus if y-intercept is negative, b. Well, the slope is what goes here, so 0.07. That's our slope. And our y-intercept goes here. It's just 25. So this is our equation. Y equals 0.07x plus 25. Now again, out of habit, I tend to use y and x to help you guys see how these questions, they'll use different letters, but it's still basically the same thing. So just pick the one that's saying this. They might have it in a slightly different order, so be careful and look out. Don't fall for this one, because that one has the 25 being multiplied by the number of minutes. Make sure you're choosing this one. That's option B. Alright, that's number 4. Alright, so let's do another question very similar to it. Let's try number 20, and hopefully you hit pause and try this one yourself first if you haven't done so already. Alright, try number 20 yourself. Hit pause if you haven't tried it already. Okay, in this situation, they give you the equation, but they want you to find the question that it fits. A good way to prove this one and feel safe about this one is to take a moment to practice finding the equation of each of these options and seeing which one fits this. Notice, in this example, 5 is happening more than once because 5 is being multiplied, but this 10 is only happening once. So when you read these questions, look for things where 10 happens once, but 5 happens more than once. So at first glance, this first answer choice says 10 miles per hour. That means that 10 is being used more than once. It's 10 being multiplied by the number of hours. So because 10 is being used more than once, this question is going to have 10x in it. So we could think of it as y equals 10x. Now let's read the rest of it. Number of miles a person walks. If he walks for 5 hours at the rate of 10 miles per hour. Okay, so in fact, this one is just y equals 10 times 5, because 5 would be the number of hours. That is not going to be anything close. No, it's close, but that's not what we were quite looking for. So not A. A's out. Okay. B. The total weight on a scale if 5 pounds is placed there initially and a series of 10-pound weights are added to it. Well, in this example, a series of 10-pound weights, those 10-pound weights are happening more than once. So those 10-pound weights are being multiplied by x, by the number of weights you add. So it's 10x. And that 5 pounds initially, that is only happening once, and it's adding to the weight, so it's 10x plus 5. Well, this is the exact opposite almost of what we need. That's y equals 10x plus 5, so that's not going to work either. All right, now let's take a look. Let's look at option D. I might be skipping C on purpose. The combined length of 5 boards, each 10 feet longer than the width of a doorway. Okay, so let's think about that one. Do we know the width of our doorway? No, the width of our doorway is x. But we know that they're 10 feet longer than the width of the doorway, okay? So the length of the doorway, width of the doorway, plus 10. We know that we have 5 of them. So we're going to take that length and we're going to multiply it by 5. And so this is what we would get there. So not quite the same thing. And I agree, it's close. We got that 5x. But if you distribute 5 times 10, well, that's 50, not 10. So that one's not going to work. So option D is also out. Now let's look at option C. Hint, hint, you might already realize it's going to be option C, but let's go ahead and make sure. It says $5 per hour, meaning 5 is happening more than once, and earns $10 in tips. Oh, that's just it, $10 in tips. That only happens once, so that does not get multiplied by anything. So this 5 per, or 5 for every, that's an indicator that 5 is going to be multiplied by something. Well, that $10 in tips only happens once. So we have 5x plus 10. That's our equation for option C. So I hope you're starting to see the point I'm trying to make when you're reading these questions, how you can tell what kind of equation they're going to be. Are they going to be standard form? Are they going to be slope-intercept form? And then use what you know about that. Slope-intercept form, this is your rate. This is your slope. If you were to graph this line, this is how steep the line would be. That line would go up 5 over 1. And that means up $5 for every 1 hour. That's how we could do that. Alright, so that was question number 20. So let's look for the next question that's going to be just like it. Let's go to number 68. Now I'm just lumping these together so you can get repetition, saying which type of questions are the same. Because honestly, guys, yeah, learning the math is good too, but we're mostly also want to be concerned with problem solving. And a big skill of problem solving is being able to look at a question and knowing what type of question is it, being able to categorize it. Makes it feel safe, makes it feel predictable, and you start to feel very confident on how to handle it. Alright, let's move on to number 68. Alright, number 68. A computer is purchased for $1,200 and depreciates at $140 per year. Which linear equation represents the value V of the computer at the end of T years? Now, I think you'll agree, the number of years goes by is going to cause it to go lower in value. So the value is going to depend on T. So the value is like our Y, and T is like our X, as far as thinking input, output, X, Y, that type of stuff. Now, let's just look at the other numbers. It has an initial value of $120, so initial value of $120, and then depreciates $140 per year. Okay, so that $120 sounds like it only happens once. It's just a one-time number. But then this $140 per year, I think you're already catching on. That's going to be happening more than once. And so that's going to be our rate. And since this is a one-time cost, since the first one is a one-time cost and this is a multiple happening cost, this is going to be a slope-intercept form question again. So y equals blank x plus something. Okay, so may not have left enough room in there. So now, this depreciates. That's a key question here. That's a key thing to realize. When it says depreciates, it's almost a vocabulary question. That means that's the opposite of appreciate. That means to go down in value. So this 140 per year is actually negative 140. So the slope is negative 140 because it's depreciating. The value is depreciating. So make sure it's negative. I don't see the positive version of it available, but just in case. Alright, well, and then we've got, or unless you did make it positive, you got excited and jumped on this option. Okay, and then the one-time fee of $1,200 is right here. Now, this equation that I just wrote is actually kind of opposite of what's intuitive. Think of this logically. it starts off with a value of $1,200, but then it goes down. So let's see, it starts not negative, starts off with $1,200, but then it goes down $140 times the number of years that go by. So this would be the more intuitive way of writing it. It's just not slope-intercept form, so it's not always my first guess, but that's the order they put theirs in. They put theirs in the more intuitive order, which is perfectly fine, but just know if you got this version, know when something is the equivalent. So option A is going to be our answer number 68. Hope you're starting to see a pattern here in how to match equations to these word problems. Slope-intercept form is a very popular version. Alright, so that was number 68. Alright, we're going to save the parallel and perpendicular conversation towards the end, but now let's take a look at number 52. Let's go take a look at a word problem, which most of your questions will be on the EOC, where it looks like it's going to be about slope-intercept form, and hence it might be going to slope in a point. That's me kind of cheating. I looked ahead and read the question, but let's go see how we know that. Let's do number 52. Alright, this question, I see the word Harry and I see wand. Oh, this might be Harry Potter reference. Oh wait, that might be infringement. This is just a Harry the wizard, blonde-haired wizard who has no scars example. Alright, let's see. Harry determined that every time he tapped his wand, the sound increased 4 decibels. Well, it said every time, so that's implying that this 4 decibels is happening more than once. So let's already think of that. 4 decibels is probably multiplied by something. Anyways, he noticed that after tapping his wand 3 times, the sound measured 34 decibels. Oh, well look what they're saying. They're saying his 3 taps caused the volume. So that's actually kind of implying the number of taps is your input. So number of taps is going to be an input, which is going to be X. So the number of taps is going to be X. And then the output, the volume, that's a result. And so you could think of this as, I'll call it decibels, so that you realize that's what I'm going to say volume. The decibels is going to be Y, the output. Okay, so the number of taps is causing the volume to get louder. So it says, which equation best represents the sound when W represents a move of the wand and S represents the loudness of the sound? So when you look at this question, you're like, okay, well, we're used to these past examples I've been doing. They've been giving us the y-intercept. But you notice here, they told us 3 times, 3 taps of the wands. That's not a slope or a y-intercept because 3 times, that's telling us how many times x is happening. That's telling us we have 3x, meaning that is telling us, I wrote that slightly wrong. That's telling us x is happening 3 times. We already knew our slope or our rate was 4 decibels. So 4 times x is the number of taps, but we know the number of taps in this example. The number of taps is 3. So instead of putting an x here like I normally would, I'm going to put a 3 here. So this is mx. Think of it that way. This is mx. So like y equals mx plus b. But we don't know b. We don't know what that starting point is. Like for example, how loud it would be with no taps. But we can look for an output. And we know the output in this example. The output was told it resulted in 34 decibels. So that 34 decibels is our output. That's our y value. So look what they did. They gave us a y, an m, and an x. They just didn't tell us what b was. But that's okay. Notice, we know everything but b. So this question is special. This question is special because they gave us the slope, and then they gave us a data point. That's a mathy way of saying they gave us an instance of it happening. They gave us an input and an output. The input was 3 taps. The output was 34 decibels. Because of that, we can treat this a little bit different. We can plug in for our input and our output and then our slope, and then to finish finding our equation, all we got to do is find b. So we're going to use some basic algebra skills on this equation to find b. I think you already understand how to solve this for b, but go ahead. So we find out that b equals 22. So let's come back to our regular equation. Our regular equation is y equals mx plus or minus b. Well, we know that m is 4, and we just found out that b, our y-intercept, was positive 22. So this is our equation. This is the equation of our line that would predict anything we want. And you'll notice that's going to be option B. Hope I'm not confusing you by repeatedly using y and x. I just do it to show you. You can use whatever letters you want, but since most of us are used to looking at y and x, it tends to help us not hesitate if we just translate in the very beginning. Now, granted, I'll give you, we didn't normally talk about how to solve these types of questions with slope-intercept form. Most of the time I did what I told you in the beginning of the video. I would have put it in point-slope form first and then solve for the y-intercept by putting it in slope-intercept form. Let me show you what I mean. Normally, I would start by putting what we know into point-slope form. So y minus y1. Well, our ordered pair is 3 taps resulted in 34 decibels. Let me confirm that. 3 taps, 34 decibels, yes. So that our y value is 34. Our x value is 3. Well, we already know, remember our slope was 4 decibels every tap. So this would be our equation in point slope form. This is the way we normally would have talked about it. So then we would have distributed, like I mentioned. So this is a good review of how to turn point slope form into slope intercept. We would distribute. You get 4x minus 12. And then drop down y minus 34. Now move that minus 34 out of there and you'll have slope-intercept form. And notice you get the exact same answer this way, and it didn't quite take that much more work. And this is the way I showed you in class, because this is more of a direct, straight to your answer way. Whereas this way we solve for b, showing our work up here, and then we'd plug b back in, and then we would be done. But this way is point slope form, and it takes you straight to your answer. Especially if they had asked for this equation in standard form, this is definitely the way you would have wanted to do it. You would have put it in point slope form, then you would turn that into standard form. So this was a review of turning point slope form into slope intercept form, or finding slope intercept form this way. So just so we're clear, this was an example where you were given the slope and a point. So that makes this a type 2 type of question. Remember, a type 1 was just being given 2 points, so that makes this a type 2 question. Alright, I can't avoid it any longer. It's time to talk about parallel and perpendicular lines. We talked about this back in section 4-4, I believe it was. I'm feeling nostalgic here. 4-4, that was the part of our textbook all about writing the equation of parallel and perpendicular lines. So let's just take this from the top. Let's start with number 55. Alright, here we are. If you haven't already tried this question on your own, go ahead and try it on your own now, just to think about it and see what you can do. Just remember what I already talked about, though. Parallel lines have equal slope. Perpendicular lines have opposite reciprocal slopes. Alright, they've given us 2 equations. They want to know which statement about these 2 lines is true. They're talking about being parallel, they're talking about being perpendicular, talking about having the same y-intercept or the same x-intercept. Okay, so that's some stuff they're asking us about. Well, it's not very easy interpreting standard form. And the thing I think most of you are always going to be comfortable doing is turn it into slope-intercept form. Because we don't know a lot just by looking at this equation. It's not very intuitive necessarily for a lot of people. What's it doing? So let's turn both of these into slope-intercept form, and then we can make a lot more decisions off of that. Start with this first one. If you haven't done so already, just get y by itself. See if you can do it. Alright, we got to get y by itself, so we need to move this x out of there. So if we do that, we'll be left with 5y equals, go ahead and put it in mx form, so negative 6x, put that first, plus 3. You could have written 3 minus 6x, but let's go ahead and put it in mx form so it's already ready to go for mx plus b. Alright, and then divide both sides by 5. Okay, and if we do that, we have y equals, our slope is what you have right here, negative 6 over 5. So our slope is negative 6 over 5x, and then our y-intercept is this one, 3 divided by 5, which is just 3 over 5. That's the beauty of this, is it doesn't actually really require that much of hard math. Most time you just plunk it down to a fraction. Big deal. It's not even that annoying, especially if you don't even have to worry about graphing it. In this question, you could graph it to visualize it, but it's not going to be necessary. You're going to be able to get the information you need just from these 2 equations. Alright, so that's the first one. So now, if you haven't done so, try the second one if you weren't able to do the first one on your own. See if you can get y by itself on your own in this one. Subtract 5x from both sides, and if you do that, you're left with negative 6y. Common mistake. People forget that minus sign means it's negative y. Well, the right side, another common mistake is people's like, 5x? No, it's negative 5x. Okay, now divide both sides by negative 6 and you're done. Now, for calculating our slope, it's the number in front of x. That's a negative divided by a negative. Well, a negative divided by a negative is a positive, so that's positive 5 over 6x. And notice, there's nothing after this. So that means the y-intercept must be 0 for it to be gone. So if the y-intercept isn't there, it must have been 0. Okay, and actually, technically, it's right here. This was it right there. Okay, so let's now look at these two equations and see what we can tell about them. We know that our first equation has a y-intercept of 3/5. Our second equation has a y-intercept of 0. Well, this said the same y-intercept, so that's out. They have different y-intercepts. Okay? Parallel lines have equal slopes. Okay, let's look at option B. Parallel lines have equal slopes. Well, this slope is negative 6 over 5. This slope is positive 5 over 6. Those are not equal, so these are not parallel. We know that. Okay? Having the same x-intercept. Well, you could find the x-intercept if you took the time to graph them, but I'm already going to give you a hint. Notice how this y-intercept is 0? Y-intercept of 0 is right here. Hey, that's the origin. Hey, that's also the x-intercept. So that line is a positive slope, so it does something like that. Whereas a quick ugly sketch of the other one, it has a y-intercept of 3/5, and then it goes down. I kind of missed. But you'll notice, this one has an x-intercept of 0. This has an x-intercept of, I don't know, positive something. But my point is, the x-intercepts are not going to be the same. Some people may already realize that, but doing a quick visual sketch can help you lock that in. So we know they do not have the same x-intercept. So C is out. Well, it's starting to think it's D. Hopefully we're right. Hopefully we don't think D is wrong as well. Let's review what we said. We said perpendicular lines have opposite reciprocal slopes. That is a mouthful, but here's what that means. Let's break that down for a moment. Opposite reciprocal. Okay, if you have negative 6 over 5, the opposite reciprocal. Opposite meaning this is negative, so opposite means make it positive. Okay, so positive instead of negative. Reciprocal. Reciprocal means to flip. So instead of 6 over 5, it's 5 over 6. Okay, so positive 5 over 6. That would be the opposite reciprocal of negative 6 over 5. So let's see what we have over here. Oh, we do have positive 5 over 6. Okay, so it's confirmed. These slopes are opposite reciprocals, which means these two lines are perpendicular. So fantastic. So it's option D. That is the answer to our question. We were able to check standard form equations and see whether they're parallel, perpendicular. We were able to talk about the y-intercepts, the x-intercepts. There's a lot of stuff you can figure out just from putting them in slope-intercept form. So when in doubt, start by putting them in slope-intercept form. It's your friend. That's number 55. Excuse my highlighting, but it's my way of keeping track of what I've done. That way I don't go back and redo a question. All right, so let's see. Number 59, it's a question asking us who's parallel. Number 60 is equation perpendicular line, and 66 is parallel. So these two, if I remember correctly, were more nitty-gritty writing equations. So let's do number 59 first. So we'll get to these ones in a moment. Those are good review, though. But let's go ahead and knock out 59 first, because it's in slope-intercept form, which is a whole lot easier to deal with than standard form. So this one should be easier than our last one. Let's do number 59. All right, which is the line parallel to the line? What? That's phrased weird. What they mean to say is, let's go ahead and scratch out this. Which line is parallel to the line? There we go. That makes more sense. Okay, so we start by looking at, well, what is their slope? Okay, well, their slope is the number in front of x. Well, the number in front of x is 8. So their slope is 8 over 1 or 8, whatever you want to call it. That's their slope. If we're parallel, remember what I said, parallel lines have the same slope. So if you haven't done so already, hit pause and try this question yourself. If you're thinking, hey, look, 8 in front of x, the slope is 8, that's my answer, same slope, you just chose one of the most popular incorrect responses to this question. No offense if that was you, but hey, erase it. No one will know. No one's sitting next to you, right? All right, so let's check the slope of each of these. The number in front of x, notice, when I do that, that's only because y is by itself, and you're in slope-intercept form when y is by itself. Y is not by itself in option D, so that's not actually in slope-intercept form yet. So we'll get to that one in a minute. So let's start with this one. A, y is by itself, so that means our slope is 2. Okay, great. Not 8. Okay, so it's not A. Y is by itself for B, it says negative 1/8. Well, that's not 8, so B's out. Now let's take a look at option D. Hint, hint, I may have skipped option C again for a reason. And I'm doing this as a test-taking strategy. I don't want you always to jump on the first one. Yeah, it's probably going to be C, but it helps you feel confident and feel secure, especially, and just to be careful, to be detail-oriented, to make sure why you know it's not the other answer choices. Let's get y by itself. So let's divide both sides by 2. And if we do that, we have y equals, well, 8 divided by 2 is 4, so 4x plus 1.5, or 3/2, whatever. The slope of that one, that means the slope of that one is 4. Well, that's not 8. Okay, so it's not option D either. Now let's look at option C. Y is by itself. It's not in MX plus B format, but it's close enough. It's in B plus MX. But the number in front of X is still your slope. So the slope of this one is 8, positive 8, just like it was for this one. So that is our winner because we want to be parallel. People may have also chosen this one because that's the opposite reciprocal, but that would be backwards. It would have been this answer choice if it was saying perpendicular. All right, well, that's 59. Slope-intercept form is so much easier. Okay, so these last three examples will be writing equations. So that's good practice because it's allowing us to practice our writing equation skills. But try not to get distracted too much by the fact that it's got to be perpendicular or parallel or whatever. Let's start with number 60. Okay, number 60 says, find an equation for the line with y-intercept of 3 that is perpendicular to the line, blah. They did us a huge favor in this question. I don't know if you noticed it. They dropped a hint and they told us the y-intercept. Sometimes they'll be even sneakier in giving you a nice hint by saying 0, 3. But you'll notice if x is 0, this must be the y-intercept. So when they give you the y-intercept, that actually makes your life really easy because y equals mx plus, we know it's going to be a 3. So we only need to know the slope. That's all we need to know the equation of this line to be in slope-intercept form. Some of you are thinking, hey, knucklehead, these answer choices aren't in slope-intercept form. And I'll say, hey, almost. So let's get that far. Let's practice getting slope-intercept form, and then we'll just figure out which one of these is equivalent. Or we could do standard form to see which one of these was equivalent. I don't know, let's see where it takes us. Before we do anything, we need to realize, okay, perpendicular, meaning opposite reciprocal slopes. Well, we need to know their slope. We don't. It's not slope-intercept form. So let's get their slope ready to go. Let's get y by itself. So to get y by itself, by the way, do this question yourself if you haven't done so already. Divide by 3, divide by 3. Okay, y equals, that's 2 over 3x. Why am I cramming that in? There we go, a little bit of breather room. Negative 4 over 3, well that's just negative 4/3 or negative 1 1/3, whatever you want to call it. Truth is, it doesn't matter. Don't get bogged down by this part. That's just our y-intercept. That's their y-intercept. We don't need that. We need their slope because we know that we're going to be an opposite reciprocal to that slope. So all we really needed from them was their slope. So again, like I said, don't get bogged down by the y-intercept. Alright, their slope is 2 over 3. Well, if their slope is 2 over 3, we're the opposite reciprocal of that. Okay, so opposite reciprocal of 2 over 3. We kind of already talked about this. The opposite, it's positive, is make it negative. The reciprocal is flip it. If it's 2 over 3, we got to flip it, make it 3 over 2. So that means our slope is negative 3 over 2. Okay, so that's what we need. That's a big indicator. So negative 3 over 2. Oh, and we already know our y-intercept. Okay, so we just need to write our equation. So y equals blank x, and we know it's going to be plus 3. Our y-intercept is 3. Now let's put in that negative 3 over 2. That's our equation. So if they wanted slope-intercept form, you're like, sweet, I'm done. But they don't quite want slope-intercept form. Theirs are slightly similar. So you've got some options. You could have done the following. You could have put it in point slope form, taken this point, this slope, put in point slope form, and then turn it into standard form or an almost standard form. Or the truth is, let's just play with this one a little bit and let's experiment to see what would give us theirs. At first glance, you'll notice no fractions. Okay, we have a fraction. Its denominator is a 2. If you wanted to get rid of the denominator of this fraction, you would multiply everything by 2. Okay, so if we multiplied everything by 2, this becomes 2y. Oh, we're on to something. They have a 2y. So let's see if that happens in any of these. Let's check that. Let's multiply everything by 2 and see what we get. Okay, so it's like the distributive property, but for everything. All right, so if we do that, we'll have 2y equals, well, 2 times negative 3 over 2. Hopefully you know this, but if not, it's okay. But the truth is, the 2's cancel and you're left with negative 3. So that's always going to happen. If you multiply something by its denominator, just the denominator cancels out. So it's just negative 3. So that gives us negative 3x. And then 2 times 3, well, that's just 6. Okay, so we have 2y equals negative 3x plus 6. All right, so let's look at these 2y examples. These 2y examples, they have x is negative 3 like ours, and 6 is positive like ours. Oh, I think I just stumbled across the correct answer. I think it's going to be A, but let's make sure. Maybe we made a mistake. Maybe we're crazy. Or maybe we're not. But what helps is sometimes just checking the signs. Okay, let's look at the next one where it's 2y. 3x is positive. Oh, ours is negative. That's not right. 6 is positive, so is ours. That one could work if everything was the opposite of ours. Meaning, if ours is positive 2y, if this was negative 2y. And if that was, ours is negative 3, so that's positive 3. Ours is positive 6, so if that was negative 6. That technically would have been equivalent if everything was the opposite. Because that means they took what we had and they multiplied everything by negative 1. Or maybe they multiplied by negative 2 in the very beginning. So that would have been equivalent. But since those are not negative, it's not going to happen. Well, it's not going to be these because those are 3 in front of the y. And you're welcome to tinker with it and see if they're the same. To close this, it is A, by the way, but to close this, to help you feel confident, if you want to know for sure, the surefire way to do it is to put all of these into slope-intercept form, meaning get y by itself. And I guarantee you only one of them will look like this. I'm not going to take your time in this video to do it, but only one of them would be negative 3/2 x plus positive 3. Only one of them. It would be option A. None of those others would turn into it. Because standard form, where this is like a freaky version of not really standard form, has equivalent versions, so they can sometimes look a little different, like you saw me playing with negatives or multiplying everything by 2 or whatever. But there is only one slope-intercept form of any line ever. So a good way, the truth detector for any equation is put everything in slope-intercept form, because you'll never have to worry about equivalent different versions. They will all look the same. All right, that was number 60. Okay, if you're watching the whole video, you've made it. We're at the very end. We're going to do one more question, and we're done. I know these videos are a little long, but hopefully you're just fast-forwarding maybe the parts you need, or if you like to if you want to watch it all for some continuity, that may help to check out a little bit of all of it. But it's really important. I hope you try these questions yourself before you've just watched how to do them. Let's jump on number 66. Okay, let's see. First glance, I see a graph. I haven't even read the question yet because I'm a rushing student. And I just want to go to the answer, and maybe it's A. It was A last time, right? Or what do they say? When in doubt, choose C? All right, let's be serious about it. It says, which is an equation of the line that is parallel to MN? I'm going to take a guess and say, let's say you're someone who didn't notice that parallel part, and I'm going to guess that one of the answer choices is probably the equation of that line. That's probably happened. So let's not make that mistake. Let's make sure we read the question fully. No, we need to be parallel. All right, well, if we're parallel, that means our slopes will be equal. So whatever their slope is, that's our slope. So let's just start with that, because that's the first step of all the linear equations, is find the slope. So to find the slope with the graphs, and be like, I don't know how, I don't have numbers, I don't get to use my beloved slope formula. And they start to freak out, because they're like, I love that slope formula, he's my friend. And you might be one of those people, and you could still use it if you got ordered pairs. 3, 5, and that's negative 1, 3. Now, or you can just count. We're going to count. We don't need to use the slope formula if it's not necessary. All right, so let's just count. Pick 2 points and count. I'm going to pick their 2 points because they're already marked. It goes up 2. It goes over 1, 2, 3, 1, 2, 3, 4. It goes over 4. So that means it goes up 2 over 4. So that means the slope is 2 over 4, which simplifies to 1 over 2. Okay, so the slope is 1 over 2. That's the slope, and we're parallel, so that's our slope also. So now, we just need to find out which one of these equations has a slope of 1 over 2, as long as that equation does not also have the same y-intercept. Because if it had the same y-intercept, it's going to be laying right on top of this. That would not be parallel. So I don't think they would do that to us, but just in case, we may want to check all of them. Don't just pick the first one that has the same slope. We need to pick one that has the same slope but not the same y-intercept, meaning we want a y-intercept someplace else, like there. That way we'll be parallel. Because if you have the same y-intercept and the same slope, you're lying on top of it. You're not parallel. You are crossing infinite number of times. All right, let's find the slope of those lines. So we get to practice turning standard form into slope-intercept form 4 more times. If you haven't done so already, hit pause and try these all yourself. Common mistake at this point, a lot of people forget that that y is going to be negative because of that minus sign in front. That would be a common mistake, so make sure you don't make that mistake. Now you divide both sides by -1, which just means change the sign on everything on the right side. So positive 2x. Well, it would help if I wrote the x. Minus 3 instead of plus 3. Okay, so the first equation has a slope of positive 2. Well, that's not what we're looking for. So that one is out. Let's now check B. Alright, let's get y by itself on this one. Let's subtract x out of there. I'm going to hit pause from these steps. You don't need to watch all this. Alright, finish by dividing both sides by -2. Make sure it's everything divided by -2 on that side. Alright, a negative divided by a negative is a positive. Remember, technically, there is a 1 right there, so it's -1. So -1 over -2 is positive 1 over 2. So our slope is positive 1 over 2. A positive divided by a negative is a negative. 3 divided by 2 is 3/2, or known as 1.5. So that one had a slope of 1 over 2. And was that our slope? Oh, it totally was. Okay, so we think we just found our answer. As long as it doesn't have the same y-intercept. That looks like, this y-intercept looks like it's about 3.5. So what was our y-intercept? Our y-intercept was -1.5. Okay, so that was way down here. Okay, perfect. So we actually found our answer. But just for, I'll hit pause just briefly for practice, and I'm going to show you those others, getting y by itself in case you'd already checked them. And then we'll be done with this question. Alright, option C has a slope of -2, so that's not ours. Let's check D. Alright, the slope of option D is -1 over 2. Not quite our slope. Alright, so it's definitely going to be option B. This is going to be the equation of the line that is parallel. Now, that's one way you could have done this. You could have also done this exact same question by doing something slightly different. You could have... Nope, I lied. They didn't give us a point. There was no other way to do this. But if they'd given us a point for our equation, we could have used that point. Now let's just make this up. Let's say they gave us, I don't know, 2, 1. We could have used that point. We could have used our slope and then used point slope form. Y minus 1, because that's our y value, equals m times x minus x1. We could have actually used point slope form if they'd given us a point. That would have been another way for us to find the equation. So keep that in mind. I just want to put that out there. Alright guys, so we've now talked about interpreting word problems into, this is number 66 by the way. Okay, so we have talked about interpreting word problems in slope-intercept form and how to know when it's slope-intercept form. We've talked about how to check for parallel and perpendicular. We've talked about how to, I'm going to say it one more time, really interpreting what slope-intercept, what that slope is. It's the rate, it's something changing, and how to interpret that and use that in questions. So if you had a question that asked you to predict or asked you to state something you know about the problem, really the key to all those is if you truly understand how slope-intercept form works, if you can find it, you then can do anything with that question. You can predict, you can work backwards, you can talk about how quickly up or down it increases or decreases. You can make predictions, I already said that. It controls the problem. It's a way to know everything about it that you need to know and actually prove it so it's not an opinion. Alright guys, I hope this helped clear up some misunderstandings. I hope to help you confirm. Make sure you're practicing and make sure you're coming in ready to go, and you'll knock out that EOC when it comes in. Just another day to show off what you know. Take care.